Everybody good? Please yell if you're not. All right then. So really what we want to be able to do is we want to make our synchronized code segments as small as possible. In this particular situation, for the add method, we might want to synchronize specific pieces. But instead, let's look at a different example that's spanning a couple of different methods here. So suppose that I have a list constructed called X, and somebody adds a 1 to it. And this is done before my threads get created or before my threads can possibly interfere with each other. And then we have 2 threads come along and both execute this chunk of code. So for whatever reason, this thread's responsibility is to get the value at position 0 in my list, remove it from the list because it's taking care of that value, and then do whatever it is that we're supposed to do with that value, assuming that we're dealing with integers. Again, who cares what it's really doing? But if this is happening, we only want to do this if the list is not empty. If you call x.getZero on an empty list, you're going to have an array index out of bounds or something like that. Whatever exception it is that our simple linked list is going to throw, not array index out of bounds, but some sort of index out of bounds exception. We're very familiar with this. So we as good programmers, we don't try to get a value from position 0 or remove the value from position 0 unless we know there's a value at position 0. So that's a good idea. But what I'd like you to do for the next couple of minutes here is think about if 2 threads try to do this, what could possibly go wrong? Well, first, what's the intended behavior? And then what could go wrong if both threads start executing this if statement at about the same time? So that's what I'm calling in-class exercise over here for 3 points today. So what I'd like you to do is answer those 2 questions either by, well, since you're all in this with me right now, if you're in the synchronous meeting, think about it. I'm going to give you about 5 minutes to think about this. You can ask me questions if you want. And once you've got it, give me a private chat message in Zoom. If you're unable to be in the synchronized session and you're watching this later, drop me an email before you continue watching the lecture. All right. So I await your chat messages. When both threads come in and they both call isEmpty when the list has 1 element in it, and then they both go inside the if statement. It's possible that if they both call get on 0, that's great because, well, it's not going to fail anyway, but 2 threads now got the same value. Then one of them is going to try to remove the thing at position 0, and then the other is going to try to remove the thing at position 0. But when the first one removes the value, the list has now become empty. So one thread successfully got a value and removed it. The other thread either successfully got a value and is going to fail to remove it because it's not there anymore, or possibly the first thread does both of these lines after the second thread has done this line, and then the second thread comes in and tries to get the thing at position 0. There is nothing at position 0. So we're going to get one of those index out of bounds errors. So that's the behavior that we're worried about in this case. Does anybody have questions now that you've seen what I'm going for here? So it's a little bit subtle. It's thinking about this in a different way than we're used to thinking about our programs, that something could possibly happen between here and here that changes the X, the contents of X, but that's exactly what happens. So anyway, if you were chatting with me at all, even if you didn't get an answer approved, you have credit for this. If you haven't, please give me a quick email later on, or if you're doing this asynchronously, give me a quick email summarizing what I just said to make sure that you got the idea, and then I'll give you your 3 points for having done that. All right. So if there are no questions at this point, what I'd like to do is take a look at one of our examples, one of our most recent examples is this ball tosser. And the ball tosser is this guy right here. I've cloned a fresh copy of it so I can modify it. And this one has a situation kind of like what we were just looking at, but it's a lot less likely to happen than the one with the get and the remove. So just like almost all of our examples where we're maintaining a list of items that are being animated, and then occasionally creating new ones, occasionally removing old ones, and occasionally painting the ones that exist, we have this shared variable called list. And it's a shared variable because multiple threads could be executing methods of ball tosser. Sometimes it'll be mouse event handlers or keyboard event handlers. It could be a paint component method that gets triggered by one of our threads calling the repaint. But ultimately, it's possible that, let me scroll down here into the paint component method. It's possible that in between the time that list.size gets called and list.get gets called and maybe list.remove gets called, some other thread is also modifying that list. And it's kind of hard to come up with a scenario in this particular case with the way that this loop is structured, where we're going to have a crash. But I think the situation that we can come up with is that we might skip frames once in a while. So some item that is supposed to be painted might get skipped over because another thread tried to add something which becomes in the same position. So the other place that this list, so let me go back up. I didn't mean to scroll down that far. My shared list is accessed twice and modified once within this while loop inside of my paint component. And down here in the mouse released, my list is modified by adding a new ball to it, a new bouncing gravity ball. So what we want to do is to make sure that at most one thread at a time can be doing any of the things that modify this list. And we could try to make mouse released synchronized and paint component synchronized, but it turns out that would fail in this case, because in this case, paint component is a method of the J panel, and it would have a different intrinsic lock than mouse released, which is a method of ball tosser. So even if that would work, even if they were the same, it would be a little bit of overkill, because we don't need to make somebody only do paint component, the entire paint component method one at a time. We don't need to make sure that all these other methods happen one at a time. All we need to make sure is that the specific piece that has to do with modifications of that list are going to be done in a way such that only one thread at a time can execute. And let me pop back to the notes here for just a second and introduce a couple of terms. So what we want to do is we want to ensure what's called mutual exclusion. You go on to take operating systems next fall or sometime in the future, you study that idea. Mutual exclusion plays a major role in operating system development. So that means only one thing can be accessing a particular resource at a given time. And here that resource would be our shared variable called list. Parts of the code that modify things that need mutual exclusion are called critical sections. So that means that we want to make sure that at most one thread at a time can be executing within a critical section, and that will ensure mutual exclusion of our shared variable. A lot of terms here, some important terms to be thinking about. But we don't want to use the intrinsic lock that comes with these objects. We would like to instead use what's called an explicit lock. And if we introduce an explicit lock, we can use the synchronized keyword in a little different way. We can say synchronized and then a reference to some object that we're going to think of as a lock. And that means anywhere in my code that I say synchronized on that same object, at most one thread at a time can be executing the body of this block. So the things between the curly braces. I think it's a little easier to see when I introduce this to the code. Rather than just jumping to the finished up version, which is over on GitHub if you wanted to take a look at it, let me do the steps that we would have to do to make this happen. So the first thing we need to do is we need to introduce a new object to serve as the lock. And I'm going to introduce that as an additional instance variable of this class. And you've probably never said new object before in your program. You've constructed millions of objects in your Java programs, but you've never just said new object. This object itself is not especially useful. And here's one situation where it is useful. I don't care what kind of object it is. I just need to have an object because it has an intrinsic lock associated with it. And I'm going to use that object as my explicit lock. So now I can put blocks that look like what we see here around the critical sections in my program. And we said there were 2 such critical sections. We might be able to shrink this one down a little bit, but to be safe, I'm going to put my entire loop into this synchronized block, which means that if any of my threads are ever executing this chunk of code, no one else can be executing this chunk of code. But that's not the only chunk of code I care about. The other place I need to do it is down here, excuse me, in the onMouseReleased or in the mouseReleased method. I need to make sure that that same lock is held by my process before I try to add a new ball. Basically what this is going to do is it's going to say, if I'm just happen to be releasing the mouse and I just created a new ball and I'm ready to add it to the list, but at that exact moment, some other thread is in the middle of paint component up here, and it's potentially modifying that list, the thread that's executing mouse release is going to have to wait its turn. It's just going to have to sit here, and the Java virtual machine will take care of the details. It will say, okay, mouse release, you have to stop and wait until that other thread gets out of the synchronized block, and then I'll let you in. Same thing if it was the other way around. If we happen to be in paint component already, executing the critical section inside the synchronized lock, and I'm releasing the mouse and I'm ready to do this. So I might be saying this backwards, but basically we have to make sure that only one or the other is executing, and this synchronized will take care of exactly that situation. So what I've just modified here is exactly the same thing you find in the synchronized ball tosser.